Okay, so we are back exactly where we left off at the end of the previous video, except that for this resistor between the signal source and the gate, I replaced the 10K resistor with a 100 ohm resistor. Of course, that's in front of this MOSFET, N-channel enhancement mode MOSFET. So that is this resistor right here between the signal source in yellow and the gate on the left. And you can see in this same screen, I didn't change the scope or waveform generator settings at all from when I shut off the previous video. So you can see things look much better. So we can go back to Mr. Waveform Generator. The frequency is 20 kilohertz, and we'll go over to Mr. Scope. And we can zoom in a little bit in time. And this looks much faster than it did before. So it's turning on quite a bit faster. So we can charge up that gate capacitance much more quickly when we're doing so through a 100 ohm resistor instead of through a 10 kilo ohm resistor. And I guess since we're here, I can go back and let's try 100 kilohertz. I wonder how fast this box can go. Let's try 100 kilohertz. Oh, okay, so now we're just starting to see the phenomenon that we saw before, except that we don't see it until we get up to something like 100 kilohertz, whereas before we saw it, I think, even around 1 kilohertz. And if you look at this, the time constant, I would argue that this time constant seems to be something like a microsecond. And that's a microsecond with a 100 ohm resistor. Let's see, so a microsecond with a kilo ohm resistor. Oh, am I smart enough to do this? Let's see, so I don't think I am. So I'm gonna try this. I'm gonna say solve RC equals 10 to the minus 6th and R is 100. Ha. Oh. Here, let's make real numbers. That gives us about 10 to the minus 8, so 10 nanofarads roughly gate capacitance. So our estimated gate capacitance is about 10 nanofarads. Actually, that number sounds familiar from past years. It actually seems pretty decent. Okay, I would say this video was a success. Alfie agrees.